Hi Pre-Calc, back to section 4.7. This is video 2. So let's go ahead and get started with the specific trig functions now that we talked about the starting point. So let's think about the sine function. Okay, so let me just put a couple of points on here for the sine function. Okay, so I'm just drawing a couple points here for us for the sine function. Okay, now if you remember what we said before, we said that an inverse has to be 1 to 1. And a 1-to-1 function passes the vertical and the horizontal line test. So I want you to look at this sine function and tell me if you think it's a 1-to-1 function. Do you think it passes the vertical line test? Right? If you draw a bunch of vertical lines. Yes, it does, right? Does it pass the horizontal line test? No, right? It fails it miserably. It fails it miserably. So how does this function have an inverse if it fails the horizontal line test? Well, if you remember back when we did inverses, I said to you that you could cut a segment of the function. You could restrict the domain to a particular segment of the function, and then that segment could have an inverse. Okay, so if I chop up this function, I could find a segment that is 1-to-1 in it, right? So like, for instance, from here to here, that, for instance, is 1-to-1, okay? Now here's the kicker, okay? Catch this part. If you're a little sleepy, wake up for a second. The way that we're going to cut this function is going to be a universal cut, meaning here in India, in Australia, all around the world, we're all gonna agree on the same cut, okay? So around the world, the agreed cut, the agreed standard cut is from negative pi over 2 to pi over 2. Okay, that is the agreed cut. So take a moment to notice that red segment does indeed pass the vertical and the horizontal line test. This red segment, if I took everything else away, this red segment is indeed 1-to-1. Okay, so under the restriction, y sine x, if I say that the domain is going to be from negative pi over 2 to 2, from negative pi over 2 to pi over 2, I'm going to restrict the domain, because the original function, the domain's all real, and the range goes from negative 1 to 1. In the original function, the domain's at the whole number line, but the restriction, we're going to stay in between negative pi over 2 to 2. The range, you note, would still go from negative 1 to 1. That would actually still match. Okay, so that is the restriction of the function. Now, this is the original function. I want to find the inverse of this function, okay? I'm spending a little more time on this with you because I think this is one of the more complicated sections to understand, but if I just slow down, it's very digestible. If you just keep at it, it's very digestible. Okay, so if this is the original function, how do you actually create an inverse? How do you create an inverse? What do you have to do to make the inverse? So I hope what you're saying is that you have to swap x and y, because that's how you create an inverse. So I'm going to do that. Ready? Here I go. X equals to sine y. And then I have to solve for y. Okay, so for me to solve for y, I have to get the sign off. Now this is not a product. I can't divide it off. It's actually the y is in the sign. It's in it. It's like your brain is in your skull. Okay, it's inside. It's not next to. Right, so my lovely candle here, the wax is in the jar. It's not next to the jar, right? That's like the sine function. The y is in the sine function. All right, so what I have to do is I have to undo the sine. So to undo a sine, I have to apply what we would call, what would be its opposite. The inverse of a sine is an arc sine. They're opposite. So an arc sine and a sine will undo each other. That's like adding 5 and subtracting 5. They are opposites. They cancel each other out. So that leaves me with a y. So y equals to arc sine x. All right, now try to wrap your brain around this because students struggle with this initially. Think about this, right? For the original function, we would put in an angle and we would get out the ratio of the sides. We'd put in an angle and we get out a ratio of the sides. This is going to be the opposite. We're going to put in the ratio of the sides. We're going to get out an angle. So try to remember, the most important thing I want you to remember here is that arcs output angles. Right, it's the inverse. It's the inverse. So instead of taking an angle in, it puts an angle out. That's the output is the angle. Okay. Now you also need to know the domain and range of this. If we were, so this is another silver lining to this quarantine. If we were still at the college, physically at the college, I had to think about that. What the heck is that? If we were still physically at the college, I would have made you memorize these restrictions, okay? But now you can make yourself a little cue card or however you want to do it for your next test. So, if you recall, when you find the inverse of something, the domain and the range swap. So the range becomes the domain, and the domain becomes the range. Okay, that's really important. Remember, arcs output angles. Arcs output angles, and these are the angles that it's going to output. And that's really important that, it'll take you a moment to get this, but it's really important that you get this because the arcs can only output particular angles. They can't output anything you want. Okay? They're really specific. So if you go to like a gumball machine, it's not going to output a chocolate bar, right? It can only output gumballs. So, yes, I'm still full of terrible analogies. I can hear somebody thinking that. But that's the idea. So this particular function can only output those angles and nothing else, okay? Just that specific range. Now, what's also important I want you to think about is if you're allowed to rotate from negative pi over 2 to pi over 2, quadrant-wise, it's only letting you be in quadrant 1 and quadrant 4. You cannot give me an angle from quadrant 2. You cannot give me an angle from quadrant 3. So the output of the sign is positive here. The output of the sign is negative here. And I'll get more into that later. But what I want you to remember is that means that you have to hang out, or you're only allowed to hang out in this area. Okay, you can only hang out over here. You're restricted from being anywhere over there. Okay, super, super important. Super important. Let's try this. All right, like I said, these are a little difficult, so don't be a hater. Don't be a hater, okay? Just give it a try. Oh, my brain. All right, so I'm going to just stress this again. You have to remember, oh wow, I'm already at 10 minutes on this video. Nuts. Okay, let me do one just to get you started, and then I'll pick up in another video. I don't want to go too long on a video. All right, now try to remember that arcs equal to angles. If it would help you, you can rewrite this in its other form, but you just got to make sure that you stay within the restriction when you give the answer. All right, so if it helps you, you can rewrite this. You can think about this as sine of theta equals to -1. Because, right, this is, arcs have to equal to the angle, so you want the angle that's going to give you a sine of -1, right? But you're only allowed to stay here, okay? So if you stay here on this restriction, where's it going to be? Would it be a triangle? Does a triangle ever equal a -1? Or would it be a quadrantal angle? Because you're allowed this quadrantal angle, this quadrantal angle, and this quadrantal angle. So I hope you figured out that it's going to be -pi/2. So theta here is going to equal to -pi/2, because at -pi/2, you're going to rotate this way. You're going to end up here. That's the unit circle. The sine value of the unit circle at -pi/2 is -1. Okay, if you, for instance, say, oh, that's 3π/2, that's wrong, because you're restricted to, you can't give an answer that's bigger than pi/2. So this gets really tricky, because you've got to figure out where the answer is, and then where it is, like, because there's an infinite amount of times that the sine equals to -1, right? There's an infinite amount of times that does that. There's an infinite amount of angles that give you that answer. But you got to give me the specific one that falls within there. And that's what makes it difficult. Okay, so this was our first answer. If you have no idea what I just said, we'll try some more, okay? Let me just end this here. This video's getting long. Okay, bye-bye.